Okay, welcome to 3.4, which is division of fractions. So we're going to be dividing by fractions. Now before I get into this, this example sort of illustrates what I want to talk about a little bit. When you add or subtract, you can only do so if you have the same units. In other words, we can add 3/7 plus 3/7 and get 6/7 because it's the same unit. There is the unit, right? Or we can add $3 plus $2 and get $5. But we cannot add $3 plus 2 dogs. What do we get? Lord only knows, but we can't do it. Addition and subtraction follow this rule. Multiplication and division do not. You can divide and multiply the units of different units, right? Different units you can multiply and divide. It's like, here's one from like 5th grade. So if this is 2 feet, and this is 2 feet, the area is length times width. So it'd be 2 feet times 2 feet, which would be 2 feet times feet, which would be 2 feet squared. It takes on a whole different unit. So that's just something to keep in mind. So here we had 10 adults, and we want to know how many pairs of 2 adults per pair we could make. So I'm going to put 10 adults, and we have 2 adults per pair. And so 10 divided by 2 is 5. The adults are going to cancel, and we get 5 pairs. So that's the answer. It's 5 pairs. The answer takes on a new unit. So 329A, it says a jeweler is planning on making gold earrings. Each pair of gold earrings will have 2 21s of an ounce of gold. If a jeweler has 2/3 of an ounce, how many pairs of gold earrings can she make? Well, you could do this in one step later, but let's do it this way, okay? We know that each pair uses 2 21s, and we have 2/3 of an ounce. So really you want to take 2/3 and divide it into 2 21s. And how do you do that? We'll get to that. Let's do it by finding a common denominator. Well, thirds can go into 21. So I could take 2/3 and change it into 21s. By multiplying by 7 over 7, I get 14 21s. So really I'm going to take 14 21s. That's how many I have. I have 14 21s. Right here, here's 21. That's how many I have. And I'm going to divide those into 2 21s. So there is 1 pair of gold earrings. There is 2 pairs. There is 3 pairs. 4, 5, 6, 7. So we can make 7 pairs of gold earrings. So we have 14 21s divided by 2 21s. Now notice, by dividing it this way, we can see that the 21s just cancel. And 14 divided by 2 is 7. So there is the way in which we can do it. Now what you could also do, we're going to find out that you can actually handle this problem here without having to do this or this. This is just sort of a visual and an idea that this can be done this way. So we're really concentrating on division by fractions. So let's look at this example. It says a French restaurant prepares a béarnaise sauce ahead of evening dinner. Each batch will serve about 10 people. The sauce requires 3/8 of a cup of dry white wine. If the restaurant has about 3/4 of a cup of white wine ready available, how many batches can they make? So if I wanted to look at the units for this, this is 3/8 of a cup, and cup per batch, and this is 3 1/4 cups. So when I take cups and divide it by cups per batch, the cups are going to cancel. I'm going to get batches. Now, hopefully you can see this problem really is about taking 3 1/4 and dividing it by 3/8. Right? And we're going to get something greater than 3. Hopefully you know that you can see this, right? When I take a number take a number around 3 and divide it by a number less than 1, I'm going to get more than the original number, right? The quotient's going to be more. So 3 1/4 is going to be difficult to deal with. So our answer is going to be greater than 3 1/4. So I'm going to change 3/4 into fourths. So there's 3 1/4. I can easily change it into fourths. 3 times 4 is 12, plus 1 is 13 fourths. So I got 13 fourths of cups of wine. So I could actually change this down here to 13 fourths. But what I want to do is I got 13 fourths divided by 3/8. And I'm just rewriting this with the units showing more. So I want to find a common denominator here between fourths and eighths. Hopefully you can see that it's not so hard to change 13 fourths into eighths by multiplying by 2 over 2. So here I get 26 eighths. So I take 26 eighths, I'm going to put that in place of 13 fourths. So I get 26 eighths divided by 3/8. And eighths divided by eighths is 1, so they would cancel. And 26 divided by 3 is going to be 7, right? Or 8, I'm sorry, 8 and 2/3. So that's the answer. I can get 8 and 2/3 batches. Now let's just look at this visually. So we changed in 13 quarters into 26 eighths. So there's 26 of those going across here. And what I'm going to do is cut them into 3/8 for each cup. So here's the batches here. And we'll put that's down here. So I have 26 eighths, and I'm going to find how many batches. So I go 1, 2, 3/8. I get 1 batch. 4, 5, 6/8. I get another batch. So now I have 2. 9, I get 3 batches. 12, I get 4 batches. 15, I get 5 batches. 16, 17, 18 eighths, I get 6 batches. 21 eighths, I get 7 batches. 24 eighths, I get 8 batches. And with the leftover, and that's where the 2/3 comes from. So the main thing to realize here is if the units are the same, that's really nice because they just cancel. So in this problem, we're going to take 4/5. I'm going to put it over here. 4/5. I'm going to write it this way. Divided by 2/3. I'm going to divide this by finding a common denominator. So I'm also going to be using this idea. This is 4/5 divided by 2/3. Another way of writing it. And I could also write it as 4/5 divided by 2/3. And we're going to solve it here mainly by using a common denominator. So the LCM is 3 and 5 would be 15. So we'll change them both into a new fraction with 15ths as a denominator. So this would be 3/3, 12/15, and this would be 10/15. So back to over here, I'm going to rewrite this now as 12/15 divided by 10/15. And I'm going to get 15th cancel, and I get 10 over 12, 12 over 10. So that's the answer. So the act of finding a common denominator and then just dividing the numerators has the net effect of simply multiplying by the reciprocal. So let's look at our original problem up here. I had 4/5 divided by 2/3. Now this is saying, I'm sorry, 2/3. This is saying that this problem here is identical to 4/5 times the reciprocal here, which is going to be 3/2. And we know how to multiply. You multiply the numerators, and you get 12/10. So look, going through all this work, I could have all this work here. I could have shortened this original problem to this and done it. It looks like that. But now we're going to prove that that is actually a fact. So in this problem, I'm going to divide this by finding a common denominator. But my whole purpose of this is going to be to show you that the end result is the same as multiplying by the reciprocal. So what I'm trying to show you is that it's 6/7 divided by 3/4 is the same thing as 6/7 times 4/3. So that's what I'm trying to show you. So let's do this. Let's find a common denominator between 6/7 and 3/4, which I see 7 times 4 is 28, and that's the one we're going to use. Multiply by 4/4. I get 24/28. Multiply by 7/7. I get 21/28. So this is 6/7 here. So 6/7 is the same as 24/28. And 3/4 is the same as 21/28. The 28s cancel. Just like when we divided, right, earlier. When we had 10 over 10, they cancel because they become a 1. So now I have 24 over 21. I'm going to break these into factors. 24 can be 6 times 4, and 21 can be 7 times 3. So 6/7 divided by 3/4 is the same as 6/7 times 4/3. which shows you that instead of dividing by finding a common denominator, what we can simply do for 6/7 divided by 3/4 or whatever is to simply leave the 6/7 alone and use the reciprocal of the second number and then just multiply straight across. So you will use this technique from now on. So here's the rule. Dividing by a fraction is equivalent to multiplying by the reciprocal. Now don't get this so you can flip either one of these here, right? This just says dividing one fraction by another is the same as taking the first number and multiplying by the reciprocal, which is what I just did. Key facts to remember with fractions. Okay, when you're adding or subtraction, you need a common denominator. You cannot add cats and dogs. When multiplying fractions, you can multiply straight across, right? So 2/3 times 5/8. You don't need a common denominator, just multiply straight across. There's an example. When dividing fractions, you can first find a common denominator and then simply divide the numerators because the denominators cancel. Like 3, or let me make it 10/8 divided by 5/8 is 2. So if you have a common denominator, that's an easy way to do it. Dividing a fraction is equivalent to multiplying by the reciprocal. So we just did some of these. So let's take 3/8 divided by 1/4. That is the same as 3/8 times 4/1, which is the same thing as 12/8. So in this example, really what we're dealing with here are units. And the other idea is the word per. So this says 12 ounces of water costs $2.40. Determine the dollars per ounce. And that is dollars divided by ounces. And the ounces per dollar. Or the ounces divided by dollars. So these are two different ways of looking at the same problem. So this is $2.40. $2.40 for 12 ounces, and this is 12 ounces per $2.40. Now, I wouldn't really expect you to be able to divide this without a calculator. So, with the calculator, this is going to be $0.20 or 20 cents per 1 ounce. What's important is when you divide these, you put them in a calculator and divide them, the bottom number does not go away, right? Because this is a ratio, right? Dollars per ounce. Same thing here. It would be ounces per dollar. So I'm going to go on my calculator and go 12 divided by 240. And when I divide this on my calculator, I get 5. That's what I get. 12 divided by 2.4. I get 5. What does that mean? All right. And this is the whole idea of units. What that means is 5 ounces per $1. So these are really called unit rates, which is per 1. So when you divide two numbers, the denominator, like 8 divided by 2, and you divide those, you get 4. But when you have units like this, the bottom number does not go away. You need that 1. I'll give you another example. Like if you spent $32 and you got 14 gallons of gas. How much does that cost per gallon? Well, you take 32 divided by 14. And in this case, I'm getting 2.29. And that would be $2.29 per 1 gallon of gasoline. So in this problem, it says determine your salary for the week if you earn $13 per hour and work 20 hours. State the equation and solve using units. Well, you make $13 per 1 hour, and you want to find the equivalence if you work 20 hours. So I would multiply this by 20 because 1 times 20 is 20. So you'd have to multiply this times 20. And you would get 260. So there is the equivalent rate. $13 per hour is the same thing as $260 for 20 hours. Notice the similarity to fractions. Really, these are just equivalent fractions. So, you remember, these are examples, so they're a little harder than you might think, right? So it says, how much time would it take for a runner to complete a 100-yard race if they average 10, and this should be yards, so you want to change that, 10 yards per second. So I'm going to rearrange this very standard formula that the distance something travels is equal to the speed they're traveling, or the rate they're traveling, times the time they travel. And as an example, if you travel at 50 miles per hour times 2 hours, you would travel a distance of 100 miles. But I'm very interested in the units, right, and how those come to be. So it asks you to rearrange this and make it t equals. So if I wanted t equals, I have this rate here. How do I get rid of this rate? I can't subtract it because this is multiplication. So the way you undo multiplication is with division. So I'm going to divide both sides by r, and I get time equals distance divided by rate. So it's a really pretty simple problem in terms of the numbers, but my interest is in the units. And so I have the time, I want to figure that out. My distance is 100 yards, and my rate is 10 yards per second. Now this is pretty simple to say, well, 100 divided by 10 is 10. But what is the unit? So I'm going to look right here closely at the units. I have yards divided by yards per second. And recall from the last example or so that division is the same as yards, the reciprocal of this. Yards per second, the reciprocal is times seconds per yard. Now if you look at this, put this over 1, and the yards are going to cancel, and I'm left with seconds. So the answer is time equals 10 seconds. So let's look at some of the homework. Here is problem 1. And this one, I'm just rewriting it like this. So you can rewrite this one and figure it out. But this one, I rewrote it. The 7th cancel because 7 divided by 7 is 1. 8 over 2 times 1 is 8 over 2. 8 divided by 2 is 4. The answer there is 4. Now this one is a little more complicated. I'm going to divide by finding a common denominator. So here's an example. See if you can follow that. And I'm going to go 10/8 divided by 2/5. I'm going to find a common denominator, which would be 40. So I'm going to change 10/8 into 40ths and 2/5 into 40ths. This one I'd multiply by 5 over 5, and I get 50 over 40. And this one I'm going to multiply by 8 over 8 and get 16 over 40ths. So I get 50 over 40ths divided by 16 over 40ths. The 40ths cancel, and the answer is 50 over 16. So I let you try that one out. What's nice about this here is I can now say, well, 50 is 10 times 5, and 16 is 8 times 2. So this is the same as this, and so 10/8 divided by 2/5, again you can see it's the same as 10/8 times the reciprocal 5 over 2. So it's kind of reinforcing the idea that dividing is the same as multiplying by the reciprocal. So you can try that one here. Try doing it with finding the common denominator here. So I'm going to do this one here. It's like, get you going on it. It says 3.5 cords of wood are needed to be moved to your house. So somebody gave you 3.5 cords of wood, right? Stacked it up, 3.5 cords, blah, blah, blah. And you're going to move that with your truck. But each truck can only hold 2/5 of a cord. And you have to go back and get another 2/5. So how many truckloads will it take? Well, first of all, this mixed number is probably best as a fraction. So this is going to be 6 7/2. So what I have is 7/2 divided by 2/5, which is the same as 7/2 divided by 2/5. Now I'm going to do this with our knowledge of how to divide. So I've got 7/2 divided by 2/5 is the same as 7/2 times 5 over 2. Which multiplying is simple, straight across, 35 over 4, which is 8, which is 32 3/4. You can't make 3/4 of a trip and stop, so it's going to take 9 trips with your truck to move this much wood, taking 2/5 of a cord at a time. So these I just wanted to go over a little bit, and I'll do maybe the first couple and let you struggle on those and leave the answers in when I do the videos for the answers. Look at this. Now I'm going to put this over 1. 50 miles per hour times 3 hours. I'm going to look at the numbers, right? So this is straight across. 50 times 3 is 150 over 1, right? Well, 150 what? That's the question. Hours divided by hours is 1. So they cancel. So it's just miles. So 150 miles an hour times 3 hours. And if you think about it, you're traveling 50 miles an hour for 3 hours. You're going to travel 150 miles. Now this one here is Celsius divided by Celsius cancel. So I'm left with the units of Fahrenheit. That's what my unit is. Now what is my actual number? Well, 5 divided by 5 is 1. 1 times 9 is 9. 9 plus 32 is 41. So there you go. That is really a conversion to tell you that 5 degrees Celsius is actually 41 degrees Fahrenheit. So hopefully you can do these two. If you can't, please watch the video on the homework for this section.